So to recap what we've seen so far, we essentially have 5 cases that we can talk about with our notation and with our tables. Where first, we have the most basic case, we have the negations, where for negations, the negation of a statement is essentially its opposite, so it has both the opposite meaning and the opposite truth value. Then we have conjunctions and disjunctions, where a conjunction is only true if both are true. And if both are true, both need to be true. Then for disjunctions, it is only false when both are false, which should hint at a thing that I've mentioned before and that we'll see at the end of this chapter. Then for our more conditioned things, for the conditional, this is only false if the first part is true and the second part isn't, if the condition doesn't hold the way it's supposed to. And then for biconditionals, these are true if the parts match and false otherwise. So, in order to help us understand a little bit more about how these things work and why they work in quite the way they do, let's actually take another applied example here where we might actually care about the truth of what we're saying here, because I've been very loose about how these things work. Let's actually see something where a statement being true might have some meaning. Suppose you receive a letter from your credit card company that states you have been assigned a super $1 million prize entry number, 66556710. If your number matches the winning pre-selected number, and you return the number before the deadline, then you will win $1 million. Suppose that your number does not match the winning number, you return before the deadline, and only win a free issue of a magazine. Under these conditions, can you sue the credit card company for making a false claim? That is, under the given conditions, is the statement, the compound statement there, that is a conditional with a conjunction inside of it that I'll talk about in a second once we set our notation, is that true given what happened? So first thing we're going to do here is define a little bit of notation for how these parts are supposed to fit together. So we have our statements, I'm going to call them P, Q, and R, where P is the statement your number matches the winning number, your assigned value is worth $1 million. Q is that you return before the stated deadline, that is, you get your number in on time, and R is you win the $1 million, because obviously in this circumstance, you don't care about a magazine. You want the money.
Show me the money.
So we're going to see here whether or not you should actually get the money. And in this case, because based on the statement given by the credit card company, what we are given is something in the form if P and Q, then R. Let me angle that off a little bit more, so it's not quite in the vein of what we saw in chapter 2. But this is the statement we have here, where if we wanted to, we could go through all of the different conditions for when this is and isn't true, but for the sake of brevity, for the sake of the fact that we've seen a lot of truth tables already, I'm just going to cut to the chase a little bit. We're going to think about what's going on in this case. So under our assumptions, we have that P is going to be false because your number is not the winning number. Remember, that's what P is there. In this case, it's not really true. And then for Q, well, you did get it in on time at least. So it's not what you want, it's not what they want, but hey, you followed the rules. Cool. At least that's true. And in our last case there, well, unfortunately, you were not shown the money, you were shown a magazine. So R is false. We have here the conditional with the conjunction where these are false, true, and the final conclusion, the consequent as it were, is false. And then here, because we have these two in a conjunction, I'm just going to group these together, and conjunctions, remember, can only be true if both parts are true. Well, in this case, that one's not true. So this whole thing is false. And that means our antecedent here, the part that we need to happen first in order for the conditional to be meaningful, isn't true. Because you don't have a winning number. And if you don't have a winning number, nothing else really matters You can't trick them into giving you the money. You didn't win.
You lose! Good day, sir!
So when we're looking at this, this hopefully illuminates a little bit more about that idea of a trivially true conditional statement. Because here, you didn't have your winning number. So this whole part at the start can't be true. And regardless of what happens beyond that, regardless of whether or not you won the money, their claim's kind of irrelevant because the condition in which anything is important hasn't been met. The most important condition in particular, that you have the winning number. So, this claim, in this case, is trivially true. Which means, unfortunately, that you won't be able to sue the magazine, and you won't be able to pass go, and you will not be able to collect your $1 million. Not even $200. You just get a magazine. But hopefully, you also have a better understanding of conditional statements, because that's what we're really here for. I'm not here to give you money, I'm here to teach you logic. Well, if you get money as well, that's cool, but it's not really my job. Anyway, that's all we've got here for section 3.4. So we're going to move on next into section 3.5. We're going to be talking about the different ways that we can present our conditional statements. See you in there.